Welcome back to Lambretta-Lutz, and today I want to make a little special just regarding the ignition system of the Chimera kit. So you would expect there is nothing specific on it, but with a lot of tests and also pain points on my own Chimeras, I really have to bring this as a special part because a twin engine really shows then it has different effects. The different effect is actually even everything is balanced, that the load and the vibration have different kind of amplitudes. That is my suggestions, and therefore you have to take care a lot of fixing the ignition system in the right way, so that you suddenly not will have due to so-called noise vibrations, a situation that the flywheel not really and magneto wheel comes not really loose, but it has some movement, and then it's like through this noise vibration almost welding on the taper from the crankshaft, and then in the end you will have a great disaster, and I will show you. So you will have then horrible marks like this, and that in the end can mean that you have to throw away the whole flywheel. So I'm not just saying it by good guessing. So I had a lot of pain point with my engine. Yes, probably it has also to do that I built a high performance Chimera that even is able to rev 9,000, 10,000. But in any case, so therefore I make this special. So while on normal engine, I never used before any special glue or more than the expected Newton meters of 68 to 70. In this case, I can really recommend this Bose glues. So, and I show it in the camera. So there is one 648, and there is even the stronger one, the 638. So you have to install your flywheel, and on some tolerances you also have to check the height of the wood rake key, that this is not coming too much outside, and that the notch, can you see it better here? So the notch is deep enough. So you should really make a dry test and a dry bolt test if this is fitting together in a good way, and that the notch that is not taking any holding force is really good, so that due to this reason the flywheel is not wobbling. The next thing that you really should take care of, and you look at it, so you can see here, I will make it close up. So here you can see it. The key is still sitting on, and I grid it down a little bit because I really want to see there is a little gap. This is just for positioning. It's not making any holding. And for me, it's more important that the flywheel is really running concentric and sitting good, rather than this woodruff key has a little bit less high. So I will modify this a little bit, and to be 100% sure, the other things that you should check is that in any case, the taper of the crankshaft is lower than the top of your flywheel. I even have seen on some strange tolerances that when you pull it down, that actually the washer that comes into it was on the flank on the crankshaft. So You thought you had enough torque on it, but the flywheel didn't have the torque to press down. So to have a conclusion or a wrap up, if you install the flywheel on a Chimera kit, you have to consider 3 things. The woodruff key should have enough play for just the position. Check the clearances if that is okay, and maybe not. The woodruff key is really in this notch too strong that even your flywheel can have a little bit of inconcentric run. The second thing is that you have still, and this is quite tight already because it's just a tenth or maybe 2/10 when I can see it, that the flange of the flywheel is significant higher than the flange of the crankshaft. It's the second point. And the next point is, now for the first installing and for making the timings that we will do, it's okay to use the normal torque of about 70 Newton meters, because you may have to get off the flywheel to then with a flashlight controlling your timings on that what you want to set. You need minimum 3000 revs on the CDIs to have from the line of the CDI the exactly timing point. So just do it with like a drill machine and giving just 1000 revs. You will see a point, but you will not see the shifting. So you will have actually a different timing than it would be run with 4000, 6000, and 7000. So you need to have minimum 3000 of revs. So you need a running engine. So therefore, the timing checking comes at 3000 revs. And if this is set for the final step, you have to take off the flywheel, checking everything, clean it up with a little bit of cleaner. Then you're taking one of these screws, you put your flywheel on it and immediately torque down to minimum 90 Newton meters. That is 20 Newton meters more than normally. You even can go up to 100. But be careful, then the thread and the nut should be in very good condition. And then don't start your engine until this is completely hardened through. That means do it in the evening and rest it overnight, so that at minimum 8 hours this flywheel can then stick on it. And then you are good to go to street. Okay? So I hope that is a very important step. And now I will go further with just the normal installation to show you some other things. And please take care of these points. It will really avoid a lot of pain. And many people may be now wondering, and how I do deinstall. Okay, so how you deinstall? You still have a puller, I guess. So everybody has a puller for the flywheel. And to get off such a glued a flywheel, you need a trick as well. So the first thing is the nut maybe had some glue on it as well and will stick. So what you have to do is getting with a heating gun and bring some heat into the nut. This heat can be up to 180 degrees, because at 180 degrees, this glue is breaking his force. So after that is done and you have the nut loose, take care that the puller heat up the whole situation here as well. So put heat into the magneto wheel as well as on the crankshaft, so that the glue that is there is breaking. At 180 degrees, it is losing the force. So if on the normal condition your engine is producing on this crankshaft more than 100 degrees, then you have a problem with the engine anyway. So therefore, in a normal running discussion, this will never get more than maybe 100, maybe 120 degrees. Yeah. So 150 is also maximum on very hard condition, but it will never exceed 180, because then your engine is already dead. So to come to the point, heating up more than 180 degrees, the force, and the glue is starting to lose his force, but it's still super tight, tighter than everything that you had before. So you need to put your puller really down all the threads, not just a few threads. You have to be sure that it goes really all the way down, because if you just stop half the way, yeah, you will need so much force. You will need so much force, and take care that you really go all the way down, all the way down, all the way down. So, and then pull it. And for sure, you need a lot of torque as well. So, and if you have the feeling it comes not loose, bring more heat into it. At a certain moment, you will break the situation. And if you then put down everything, you have to clean it, sure, from the glue and put it down. But what would be the reason if you making a checkup of the timing already and the whole engine is running? This is a super good electronic ignition from Ducati Electronica. So if you're making a proper installation, if you having everything set up in the right way, the timings are fitting, that is the last installation step with the glue. Not in between. If you are installing then and making timing check, then the normal procedure like you do in every flywheel is okay. So the installation of the coil plate is quite easy, but obviously not on this engine. Okay, here's a very sharp corner, so I don't like this because it just gives a possibility to bring it on one point through. So I will grid down this a little bit to have not too sharp corners for this to break. Another point, what I will change is on this Uni engine, there comes this rubber solution. Yeah, so the cable from Chimera could easily go inside there. But what I recognize is because of this connection, I cannot go through. So I either will cut it here, or I will make the hole bigger. I will see what is the best solution. Within the kit, coming this here. So, and they are easily to slip over, and then you take the other one and slip over from the other side. And then you have it fixed like this. But I did recognize on my engines that these corners are still very sharp, and they will breaking this kind of protection soon or later. And if you are going to change it maybe for a gray to have an original look or whatever, then you have to change it as well. So this is a good and quick solution. It's coming with a kit. For this engine, I will take back the Uni one because I like more this rubber style and it will protect this more. So now I will do some modification to fit it. So with this kind of drill, it was an easy job to widen it. And so it's still proper sitting. Now it's easily fitting through. And honestly, now it's nice and smooth. It has the right diameter. And oh, I didn't check this. I have to modify this as well. So the hole, is now changed as well. The seal has anyway a good dimension. So now I will get the sharp corner seal away. Enough. So some compressed air. Okay. So, and then we can go for the installation. So, like normal, you have here the points, and in most of the cases for the ignition system, these marks are fine. If you have somehow the barrels tuned and you're looking for much higher performance, then sometimes this is good to have it a little bit more like this, that is roughly then 16 to 15 degrees, and you can start with this as a starting point. But for normal juice with unported barrels, here you will have between 17 and 18 degrees. That is okay. Yeah, and the CDAs have no re-advance or any change of the ignition curve, just much over 11,000 they have a change in the curve, but none of this engine will, of your engine for sure, will be running at the speed. So I will put it down in a normal way so that it will change, because here we will put the press down as well. And well, we fix it for this first. Here, normally the bolt, as I show in the other part, should be out 30 millimeters. That seems to be just roughly right. So maybe it's good to do a little bit more of 15. So if it's too far down, then please correct it. So, and now this one goes down. Okay, good. So, before I go now with the top, I want to check some clearances. So first, as I said, yes, the wood roof key is okay, but I will grid it down a little bit. The normal height of a wood roof key is... No, that is not true. So it's about 6.5, 6.4. But so this I just put roughly 1/10 of a millimeter down, and that should be already enough. Okay, so you can still, no, you can't. So you can still see there is, it's looking out a little bit, but for sure. Now, yes, so you may have how it did look before. And I hope you can see. So now you can see that there is a little gap. And as I said again, this is just for the positioning. It was a good advice from my perspective to really have this kind of clearance that then you can pull the flywheel down. So I will take it off again because I really want to get another check. So the first thing is I will torque down that with a necessary torque of 11 to 12 Newton meters. So I recommend to do it with 12. That is a maximum that the M6 can carry without any harm. So that is 12. So I will go opposite because that are the beams who are going through. These beams are going through as well. I'll put more down. So this, okay. And the last one is this. That is all the beam that is going through all through, and this is just the bolt that is just sitting in the mark housing. So with that, I may go down because it is not bringing down the mark housing as well to 11, because it's just sitting in aluminium from the fusion housing. So, okay, now everything is tied down, so I can be sure that the anchor plate or coil plate is completely set down. So it is also a good advice to check the clearance of the magneto. Sorry, about the pickups to the flywheel here. How you do it, because you cannot see it anyway. So for me, again, this is good solution of just putting Play-Doh on the top or any other thing that has enough space. So, and then it will be enough just to put it down. Okay, good. So, and you can pull it down. I will do it for the demonstration. I will pull it down with just a few Newton meters. So just that it is knowing that it sit down, I will take the maximum torque that is here. Hold it directly. So this is 30 millimeter. So now we will check if the clearance is given. So with this little torque here, it is enough to have just a few threads. Okay. Okay, so anyhow, we see there is a lot of space. So there's a lot of space and clearance given. So there is no worries about it. That is, I will not even measuring, but to have here clear. So we have about 2.6. And on the other side, we have about 2.6. So it's good. We have checked the clearance. So therefore you can be good that here the clearance from the top is given. If for any case you have the situation, you're putting out the flywheel and you're making a few turns and you're putting it off and you see here the flywheel has some rubber of this, check how much it is. From the very beginning, because everything is so tight in tolerances, it can be, and even here you can see, there is a little rub of this metal plates here. Can I recommend it to, and I just see, why is it here? Here is a very sharp corner. So there is a very sharp corner. So check if there is just from the production, for whatever reasons, a sharp corner. And I don't know why is it here, in this case, so sharp. And just a tenth of a sharp corner is enough to leave a mark on the magnetos. So now it's gone. Here is smooth. So and compress air. Here's everything clear. So that is now ready for the for marking the top dead end, and for that I will turn over because now I want to mark. So the height of the pickups is okay. If for any reasons this is not fitting it, you have to lose from behind these two screws. You can go it from the back. They are glued, so you can lose them. You can get up all these coils, and then on this plate you have to grid down and machine down the sit of this accordingly to this situation. So if you have to do it 1/10, 5/10, or even 1 millimeter, depends on your situation. Yeah. So it really can going to happen. For instance, if you have old mech housing that has maybe a different kind of measuring, or for instance, you mixing parts from Uni and Innocenti, or you are need to have clearance from the side part of the crankshaft, a huge spacer, so that will lift up the mech housing, and then the tolerances is not in line. Okay, so but you know now how to find the solution, and now the next step is having the upper depth point. So for this, for sure, I will install the flywheel. I have to, always looking that the cone and the taper is clear. So, and for this now, I will tear it down really already with at least 60 Newton meters, because if I will then run later the test and I forgot that I put it down with Newton meters, and I start the engine, let it read for 3,000 revs, then it would be stupid, because you will destroy all the taper in the beginning. So therefore, not waiting, putting it to 68 to 70 Newton meters. Okay, block it, and click. So that is good enough for the test. It is not good enough for a normal run. Okay, good. So as this is done, I will swap the engine in a new position, and then we're going to finding the upper depth mark. First thing that I have to do is putting a piston blocker into the plug hole. You can get you can do also you know, drilling just a hole through a old spark plug and making a screw into it. So, and now we will install the digital measuring for finding the depth upper point. So for sure, some of you have this kind of tools that you can buy directly to have it like this. I do it a little bit differently. I have this kind of clamp that gives me the situation to do it on different engines, and I have it modified because I have different kind of flywheels, so that I can even use it to the other side. So that is for me my universal style device. So for sure, as I said, we have different solutions. You don't have to copy like this. I'm happy with my solution. So I put it to 0. Okay, so now I'm turning the engine to this maximum. So I have here 177.8. So taking my calculation, 360 minus 177.8. 177.8. So it's 182. And this divided by 2 plus the 177.8 is at 268.9. In this case will be the upper dead point. So we go out with a piston stop. Okay. And now we go to 168.9. So 168.9, a little bit more. I mean, you will barely have the chance to check it then later on this 1.008. So you can mark now on this flywheel on 1, 2, 3 different positions the upper depth point. So you have here on this flywheel a mark as well. So you can put it here on, and could also make it a timing check as well. But as you have here holes and threads, and you can have a little bit of variance, it can be already making 1 degrees on your ignition timing different. So therefore, make a mark here, and make a mark where you know that you have easily access then with your piston gun. You can make here now a mark of 0. In this case, for the picture, it is easier for me to do it. So you can mark it here. How do you do it? So I have here this special central linear, and for me, it's now because I have light coming from the top. I have here a shadow, and this shadow line is straight. So for me, it's even there is a distance, and not to get a parallax mistake, I put now the shadow directly at the 0 mark. So, and with that, I can be 100% sure this line is completely accurate at O. So, and now I can now turn the flywheel further to plus 70 degrees to 284.9, and I have 70 degrees. But as in a general way, I have here the solution to, but now I can't because this is stopping. Okay, then we do it a different way. We do it as we have know it. So we go now to 185. So we have the 70 degrees that we taking, and again I taking this, going to the to the 0 line because we turned it. I have again the shadow that is now exactly marking me the line. So And now I have here my mark for the 70, and I have here my mark for the other dead point. And normally to have not so many marks, but in this case you want to have here now the mark of 70 degrees. That you will mark, and you want to mark your upper death point. So you can make it stronger. In this case, I will later do it here in the top. So because then for the timing is better. And so we have put now the ignition point. So we can put this away for when the engine is running at 3000 revs. We have now our point where we can see it. And for sure, on this, it would be then better to have here a wire that goes directly until this mark to have a closer view on it, because on this distance, it is hard to see. And now I can show you why I'm not doing it with this flywheel. So in case we're putting it on a flywheel, so first the mark will be on a completely different side. If you are sure that this flywheel, if you have a flywheel blocker, is not connected, but I want to demonstrate you actually the situation that is going to happen, or can happen. So I have here the mark. So, and you see, you cannot be sure that you will always install it in the same way. So this is already blocker 1 degree. So therefore, you set up the ignition once without the flywheel. You mark it in a traditional way, 0 ignition point, 70 degrees, 16, 15, whatever you like. To be more safety, you go to a 16 or 15. The normal one is 17. Some people recommend to go 18 because it's a best performance. I have a different opinion on that, and I will give not any advices. So I will stay on the 70 degrees that you find in the most workshops. So with that, you have now set up this situation. So I would leave it as this. I would then go to the next part for installation of the drive side. So again, for me, important is, and I will say it again, the final installation has to go with this kind of glues, either the 638 or the 648. And then, and I will mark it here, this nut should be not longer just with 70. It should be tear down with 90 to 100 Newton meter. So I write it down, and that is what is important to do. Otherwise, we will get problems here, and you don't want to destroy your ignition system by just missing 20 Newton meters. I hope you liked it. Please comment. Maybe you have some experiences with your Chimera as well. I would like to know if you have the same experiences. And please subscribe, please comment, leave a like, and see you next time on the next part.